Everyone, welcome to my YouTube channel Psychology Class for All. In this video, we will discuss effects of linear transformations on measures of variability. Let's start with a quick test. Suppose we have a data set with a mean of 20 and a standard deviation of 5. Now imagine we apply these two transformations. First, we will add 10 to every value, and then in the second chance we will multiply every value by 2. Here is the challenge. After each transformation, what happens to the mean and the standard deviations? There could be few options for that. Option A, both mean and standard deviation increases by the same amount. Option B could be mean increases but standard deviation stays the same. Option C, mean and standard deviation both doubles. Option D, mean changes with addition but standard deviation doesn't. So linear transformation don't affect measures of variability in the same way they affect measures of central tendency. Linear transformations of the scores involves actually changing every score in a data set by adding or multiplying by a constant. Adding a constant shifts all scores equally, while multiplying by a constant value changes both the scores and their variability. Here I have displayed the two bar graphs. Both the bar graphs have got same data pattern. As you can see, the first blue color displayed bar graph is showing marks out of 50, marks of different subjects out of 50, and the green colored bar graph is showing the marks of different subjects out of 100. Actually, just to show the transformation, I have added, I have just doubled all the scores from 50 to 100. A linear transformation means changing every score by adding or subtracting a constant, multiplying or dividing by a constant. Why do we use it in psychology, or what is the benefit, or what is the application of it? First one is standardizing scores. It means converting raw scores into a common scale. It helps in converting raw scores into a common scale. Common scale, for example, Z scores, to compare results across different tests or distributions. Adjusting psychological scale data. It involves transforming scores to correct bias, reverse items, or align scales for accurate interpretation. Third is rescaling test results to different formats. It changes raw scores into new scales, for example, 0 to 100 or percentile ranks for easier reporting and comparison. How measures of variability react to linear transformations. Here there are different options or different uh, statistical tools of measures of variability, and the two way of transformation: first is adding or subtracting with a constant, b is a constant; multiplying or dividing with a constant, again a is a constant value. If we add some number as a constant, then range has got no change, quartile deviation shows no change, average deviation, standard deviation, as well as variance shows no changes. While if we multiply or divide the scores with a constant, then range, quartile deviation, average deviation, standard deviation, even variance also shows the multiplied effect of the value. This can be seen in this animated scale. Only multiplying changes variability, adding just shifts the positions. We can see it with an example. Here in this example, these are the original scores that I have taken: 4, 6, 8, 10 and 12. The mean value will be, after calculation, will come as 8. Standard deviation is 2.83. Transformation form 1, that is, will be adding plus 5 to all the scores. So the new scores will be like 9, 11, 13, 15 and 17. The mean likewise will go for 13 and the standard deviation will go for 2.83. We can see that while adding plus 5 to all the numbers, a mean has got the change as the constant value, but standard deviation remains the same. Now transformation part style 2 or transformation part 2, multiplying all by 2. 2 is a constant value. So the new scores will turn as 8, 12, 16, 20 and 24. And then mean value gets doubled. It's like just multiplying 8 by 2. It's 16, but there is a change in standard deviation. It also gets multiplied by 2, like 5.66. Just double. Stay connected to learn statistics in an easier way. Thank you.